Hello, my name is Lisa, and I will be doing my presentation on a conic called the Ellipse. So before we start, I should basically explain what a conic is. And so a conic it's abbreviation for conic sections, and they are curves that result from the intersection of a right circular cone and a plane. And the conic I've chosen, as I said before, was a lisp. And so basically a lisp is an ellipse is an oval or squished circle. It happens when the plane is tilted slightly so that it intersects with each generator of the scone. The center right here is the midpoint joining both of the foci, or the focus right here, of the ellipse. And then the foci are basically the sum of whose distance from two fixed points. And then you have the major axis right here, which is the lining containing the foci. And then you have the minor axis, which is the line through the center and perpendicular to the major axis. And the 2 points of the intersection of the ellipse and the major axis are the vertices. So the ellipse has two equations, which is the major axis right here, and then you have the vertical major axis. And for the horizontal one to happen, the center has to be at 0, 0. And the foci has to be a negative number and 0, and then its second pair is a positive number, then 0. As you can see right here, I'll make an example. So the center has to be 0, 0. And the foci, basically, instead of putting the whole thing, you put F1 for the first pair right here, which is a negative number, unknown number. And then you put 0. Then F2 will be right here. It will be a positive number, and then 0. And then lastly, you have the vertexes, or vertices, I guess. That's how you pronounce it. I apologize. Same thing. You have V1. It's going to be a negative number, and a negative unknown number. And then you have V2. I'm sorry, my 2's don't look correct. So basically, a positive number, and then 0. See, so these are for the horizontal, which runs on the x-axis, which is right here. So, but for the y-axis, it's going to be the complete opposite. So instead of the usual unknown number c or a, it's going to, being on the x part of it, it's actually going to be on the y. And then the 0 is going to be in front instead for the major vertical axis. So it's basically going to be switch swap. Switch swap, doop dop. I'm sorry, I can't even say it right. But let me continue now. Real life. Ellipses are found in many applications in science and engineering, things like that. And scientists usually use it to measure how we, the Earth, well, our Earth, orbits around the sun. And they also use it when taking temperatures of how much heat we absorb, such as that. As you can see here in this little photograph right here of the picture. It's also in foods as well, like watermelons and avocados. The ellipse is right there, as you can see. I made a cute little diagram of it right here. It's also when little kids are using hula hoops, are also there. So you can imagine a kid like hula hooping right here, and there's the ellipse basically. And then you have for diamonds. Basically, we can engineer gems and things like that. As you can see, it's perfect ellipse. It's not, I didn't make it correct or something, but I mean, it's close. So let's continue on to the next slide. I would like to study neurology and become a nurse practitioner so I can specialize in the field. I also hope to go back in the future again so I can actually become a surgeon to actually work on the brain and the central nervous systems and things like that. And my 2-year plan is to finish my classes at my current school and then transfer to a bigger university. And after graduation, I hope I can transfer to Washington State, which actually has an amazing medical program, and to basically do medical school there and residency. And I didn't know that I can find actually a list in neurology. I thought that I didn't really know you actually have to use that kind of thing in neurology, but you know, you live and you learn. And so basically right here, as you can see, they actually use a list to find like certain places that have seizures, certain parts of the brains where seizures like start and everything. As you can see right here, I made a little example of it as well. I made a list and what it would look like right here. As you can see, you have the center and the vertex right here and the foci and everything. So it's really interesting to learn that lists are basically everywhere. Usually they tell you like, I usually have like that saying like, what am I actually going to use this for? It's not really important, but now I can actually see that this might appear a lot in my future as I progress through my medical career. So lists are also used in other fields of medicine, nephrology, which is basically the study of kidneys and the conditions of kidneys, et cetera, et cetera. And it's not really a field I'm interested in. As I said before in my previous slide, neurology is more my thing. But now I figured out that they also use it in kidney studies as well. And it's they use list in a process called lymphotripsy. I'm so sorry, I cannot pronounce it for the life of me. And so basically, it's a process in when a medical specialist uses the list to create a device that effectively treats kidney stones and gallstones, which is basically right here, as you can see. And so they use a lithotripter, which basically creates sound shock waves or sound waves, things like that, that successfully shatter kidney stones and gallstones into tiny pieces, so it can actually go through your body much better. And as you know, kidney stones and gallstones are very painful. So this actually saves surgeons a lot of time instead of actually, you know, cutting someone open, doing surgery and everything. It's actually very helpful. And I'm quite surprised that they actually use a list for that. I didn't even know until I researched it. So it's very interesting, and I'm very happy I chose the topic of a list. I didn't know I was going to find that they actually use this in real life. I thought they would just use this for other things. Um, like you know, like like the way architects use these kind of things to build. I didn't know they're actually in you actually use them in the medical field as well. So this is going to be a lot in my future. So this is very interesting to see. So thank you so much for listening. I apologize, I stutter like a ton, but I hope you can understand, and thank you.